Okay, so hello everyone, and I welcome you all for another session of daily lead code practice. And we have three questions from Easium, Medium, and Hard. And let's start with the first question. And I'll share my screen first. Let me share my screen. Okay, so you all can see my screen.
Yes.
Okay, so this question is shortest completing word. Here, the in nutshell, I can say what we have to do. So we are providing with one particular string, which is this, for example, and these are the list of words. What we have to do, we need to see what are the characters in this particular string are present in any of the word, and the one thing is whichever string or word is making that particular string, and whichever that word is the shortest one, that word is an answer. For example, here we have SPST. So we have like the string which we have is SPST, and from the words over here, when we search from a step, we don't have one more s, so it's contain stp but not one more s, so we need two s over here, so this is not an answer. So when we move to steps, it is an answer for us, which is because it contain all the characters which we need in here, and it is the shortest length. This word is the shortest length from all other length. And when we move to stripe, it is not an answer because s is not there. If that word is a stripes, then also it is not an answer because this is the its length is more than this which we have found. So this is the main question which we need to solve. And one more example is this, where
Sonia, I have a
sorry,
question. I have a question regarding the example one.
yeah.
So, in case of second string STEPS,
Mhm.
what if there is like an additional S there? Let's say STEPSS.
That's not a problem. You need to have all the characters, at least all the characters which are over here. And but the thing is, if there is one more s, then I think this length would be similar like with this length. This is 1, 2, 3, 5, and this is 1, 2, 3, 4, 5, 6. So then yeah, so this is will be steps, like with six characters, and this is also six characters. But the word which comes before, like first word which we seen, it would be an answer. For example, over here, so this is
So just to say, the example that I gave STEPSS will be the answer, but not the stripe because stripe contain only one S.
yes, yes,
Okay, makes
yeah,
sense. Thank you.
yeah. And over here also, we have one single character s. In these words, all are having the single character s, but this is its length is more than this, and so this would be an answer. And although all these three can be an answer, but this comes first, so this is an answer. This is our answer. So anyone has tried this particular question? Any approach? What to think? How we can solve it?
The brute force would be to to sort the word by length, and then just compare one to one from left to right to see, you know, if this if a word from the you know, if the number of character count is met.
So you are,
we sorted, so we guarantee that the first. Oh no, wait. If we sort it, then the the order may be not. May yeah, we may not have the right order in case of example 2.
so you are saying to sort, like you want to sort the word like this or this particular string as well?
No, only the words.
Okay, so but in this, like in a string, we have a like numerics as well.
No, it's sort by length of the word, but never mind, because you know, I look at the second example,
Mm-hmm.
that's not gonna work.
Mm-hmm.
The proof false should go, you know, one by one, and keep track of the minimum length so far.
Yeah. Yeah. So anybody else? So one approach which I am thinking is like if I just take only the characters from this particular string and sort it and then traverse one by one to all these strings and also and I'll just check and also sort this one by one all the characters and I just need to check now if that particular string, the substring of this is present in that particular string or not in that word. So if it is present, then whatever the length, it's an answer.
It may not work if, for example, you know, one string you have 2 s, and the other string, you know, the first string, the license plate, you have only 1 s, and you know, the other one you have 2 s, and when we look for the sub string, we don't find a match, but you know,
Why we don't have a match? Because you are saying over here it's just a one string and over here, for example, there would be a 2s.
yeah.
That's not a problem. So you at least you need to have one at least character.
Yeah,
Whatever
but
the character you need.
let's say you have, for example, for the first license plate, you have letter A, B, C, right? And then,
Okay.
yeah. And the second one, you will have A, B, B, C. Then if we look for the substring, we cannot find the substring in there.
Okay, so you are saying, yeah, that would be a problem to getting a substring from there. So we can go for a two-pointer approach over here. Whatever the characters we need to match character by character with the string.
Yes.
Like if A would be matching with A, B is matched with B, and if it is like next is also B, we just move ahead, and next if it is C, then we'll match. I think the matching which we solved the previous one questions before, one of the questions which we solved, that approach can be helpful over here also by comparing the character by character with other string.
Yeah, but we don't need to sort them. I think we should do the character count.
We can use a
sorry.
We can use a separate data structure to store the count.
Like a map.
Yeah, maybe a map. Yeah.
Yeah, that's another approach to, like you're saying, like first of all we need to create a map for this. So is there any problem with the last approach?
Which last approach are you talking about? Sorry, I didn't get that.
Sorry?
Which last approach were you talking about?
So which we were solving, like first of all we started with the substring, but substring would not work. Then we started with matching each character by sorting. So in that, is that like we were discussing, it is required to sort or not?
I mean, if you are storing the count, then we need not sort them, right? That's my understanding.
Yes, like sorting is not required here because all we need is count. Okay, given the license plate and the list of words. Okay, any word can be in any, like the characters in a word can be in any order. They doesn't need to be like in the same order. Okay, so sorting is not required. If we can just like calculate a count of characters in the license plate, store them like in a hash or like maybe array of 26 characters.
That also works.
Okay, and then so we can calculate the length of that array for the license plate, and then for each words. Okay, one way is to calculate that the similar array for each word, and then compare with the license plate array to make sure that all the indexes, let's say number of A in the license plate array should be number of like A's in the words should be great, like in any word should be greater than or equal to number of A's in the license plate. Correct?
Yes.
And then we do the similar comparison for all the 26 characters. And if it holds true for all the 26 characters, that means in any word we are getting all the word letters which are in the license plate with the count greater than or equal to in the license plate, and we are good.
So in this, are you trying like how we'll be searching in this particular count? Like here also we need to create a hash map or take an array for like 26.
Yeah.
Can
you do it like for the example, like first example? Okay.
So yeah. So for example, over here we have S2. Sorry. S2, P1 and
S1, T1.
T1, yeah.
Okay.
And
now,
for step will be we are having 1. T is 1, E1 and P1.
Okay, now if you assume like this is like in an array where you are going from like 0 to 25. Okay. So or you can like even use a hash map. Okay, it doesn't matter. See like for the first word S. Okay, first letter in the word S.
It's
the count of S. Yeah, it should be greater than or equal to the count of the previous one.
Yes.
Correct?
Yes.
Similar holds for T, E, and P. Okay. So in this case, the count of S is less than the count of S in license plate. So we cannot like take the word step. Okay.
So like I'm just saying, like if we got to know that we require 2, but it's only has 1, so we'll just break and go to another.
Yes. Yeah, second word. Yes. We don't need to keep comparing. Now Now, if you take the second example where S
Yeah.
is 2,
S is 2.
okay, so this satisfied our constraint.
Yes, and we take the length of it,
No, like
which is,
we just stored this steps like in the array, like maybe in the result.
yeah.
Okay, and then we keep moving forward. If we find a word with a smaller length than the previous results, then we replace it.
Yes. Okay. Yeah, that sounds like an approach to me. Yeah. So anybody have questions on this approach and wants to discuss about it? First of all, and anyone has any problem on this approach? So what's the time complexity of it? It should be like traversing the words would be order of n, and creating a hash map for each word would be an extra step. But
Yeah, so the time complexity, how you will like calculate the time complexity of this problem?
so first of all, order of n for all the words traversing.
Yeah,
Like,
so let's say like if there are n words,
yeah.
okay, and let's say the length of the longest word is m or l. Okay, length of the longest word
Okay.
is m. Okay, so it should be n cross n.
Yeah. So, and creating a hash map also would require, or any like taking an array also require, like counting them would be an extra extra computations to do
Yes,
that.
when we are comparing them, like yeah, it's extra order of 26. Okay, but again, like that's a constant. Okay, so even like if you do that, it should be order of n cross m, where
Yes.
n is the length of the array, and m is the length of longest word.
Longest word, correct.
Then what would be the how would the license plate involved in the time complexity?
For license plate, what do you think?
It would be only the length of that characters, and creating a hash map of it, which would be order of, let's say, L, if there is a length of L is a character.
Yes, so it's constant.
Yeah, it's also constant. So any doubt in this?
So the time complexity would be finally would be m n cross m. Yeah. Any different approach? I mean, this kind of seems to me we do kind of like. I mean, is there a better approach than this?
So when we calculate the time complexity, in most of the cases, we don't calculate the time complexity of the longest word. Let's say like the longest word, itself like should be the constant. Okay, so in most of the cases, we calculate the time complexity as order of n, which will be the length of the array. And now the question is, can we do better than order of n? Okay, better than order of n is maybe log n, but anyway, like we have to go through the whole array up to the last to figure out is there a word maybe at the very last index which might meet the requirement and is the shortest word, length word. Okay, so anyway we have to traverse the whole array. So I'm not sure like if we can do better than order of n.
When we traverse the array, for the word that length is smaller than the license plate, we don't need to compare it.
Yeah, we don't need to compare it, but anyway, like we have to traverse the whole array. So
Then-
in this case, like the first step, it is like not matching. So let's say like we ignore it.
Mm.
Then we have to go to the second one, third one. Let's say the second one we found an answer. Okay, but let's say there is an word at the very last of the array which is shorter than the second one, assuming. Okay, so anyway, like we have to go through the whole array.
Yeah, but like, it may not be gain a lot of performance, but we can like move everything, all the word less than the length of license plate to the left, right? Then we know we don't need to search for those words. We can keep track of the index at where we start to search.
Agree. And then how will you move those?
Oh, just swap them.
Yeah, like you will swap them, like
Oh, yeah.
so
Yeah.
for moving to, like, you have to iterate the whole array.
Yeah. But it's only big O of N, right?
Yeah.
But what would you think about, like, I'm thinking of this approach, but I'm not sure if that workable. So let's say I create a map, and let's say this map the key will be a string that would say, let's say here's all the words that have 3 S in it. So the key will be 3 S, and the value would be a list of words that have, that have 3 S. And I create a map like that. Then
Yes.
Then I look at the license plate, and then count the character, and then I look up the map to get a list of words, and then I just do the union of them.
Sure, like that approach, like I'm not very sure, like I'm getting it fully, okay, right here. So why not, like, maybe if you want to try it out, okay, try it or post it in the Slack channel, okay, and then we can have like that discussion there, okay, because that way it will be easier for like folks to jump in.
Yeah.
Okay.
Yeah. That's
Okay,
kind of
so-
like the. Sorry, go ahead.
No, it's okay.
No, that guy, I think it do with like inverse document, like Google inverse document. So kind of you search for the keyword, and then you merge them, right? In this case, the keyword will be how many character A, in the license plate, and how many character B will be license plate. And then when we find it, and then we kind of merge the answer to get a single one. But
Okay. So anybody wants to discuss this, or shall we move further? Okay.
yeah, I think we can move to the next one.
Okay, so can you all see my screen for the next question, or I need to share again?
Yes, I can see it.
Can you see the second question?
Yes.
Okay. So yeah, so this question is like we need to filter, like we will be providing the restaurants where we will be having the ID, its rating, like vegan friendly, price, and distance. And you have to filter the restaurant using 3 filters. First of all, if it is vegan friendly written, then, and if it is vegan friendly is true, meaning that you need to take all those restaurants which has vegan friendly. And if it is false, so all the restaurants, even the vegan friendly restaurants, are included in it. In addition to it, the filters is like max price and max distance, like whatever the maximum value for price and distance they are saying, you need to find the restaurants in that particular area or distance, or a less than that max price. And first, what we need to return is we need to return the restaurants IDs, like after filtering by their rating. So this is a rating. So whatever the highest rating that particular restaurant is having, we need to filter, and that would be the first one. And then if the restaurant has the same rating, then we need to order them by ID. That also from highest to lowest. I think for restaurants for the same rating, order them by ID from highest to lowest. Yes. And for here, for our sake, they are saying that vegan friendly and vegan like one would be true and 0 would be false. Like if it is vegan friendly, then it is 1. If it is 0, it means not vegan friendly necessarily. So let's take an example over here. So this is an array. Sorry. Okay, so this is an array. And so what it is like, so it is saying vegan friendly should be true. So we just need to filter it out, those restaurants over those lists which are vegan friendly over here. So, and vegan friendly is our third index. So this is a vegan friendly. And this is also vegan friendly. And this is a vegan friendly. So now it is filtered out on the basis of this. And now next is max price should be 50 and max distance is less 10. So we have a max price and max distance. So first of all, if we want to filter on the basis of max price, so all the restaurants which have less than 50, yeah, they are less than 50. So this is 40, 30 and 15. Then it should be less than 10. So this is 10, this is 4, and this is 1. But I think, yeah, so this would be fine. So now we have these 3 and we need to return their index, which is like, I think this is 0, 1, 2, 3, 4. We need to return their index on the basis of the original array. So
we have
now,
we have written the IDs.
Yeah, IDs.
Which is at the index.
Sorry. The ID, yeah, sorry. We need to return the IDs on the basis of, first of all, the rating. So this is the highest rating. So first answer is 3. Then other rating is, this is 4. So this is also highest, and then it is 1.
So can you write it down in that order?
So yeah, so now our answer is 3, 1, and 5, because this.
So can you first write down those elements in that order?
Sorry?
Can you write the?
Yeah, so I've thought it down. Okay.
Just to be more clear.
Okay.
So first, we are sorting it by rating.
Yeah, so we are sorting it by rating. I'll write it on that as well. So this is sorted by rating. As it is not containing any duplicates of ratings, so we don't need to. So it is not sorted on the basis of ID right now over here. But for example, if we over here also, if we have a 4. Because now it's having the same rating, then it would be reversed, because on the basis of ID, they are saying order them by ID from highest to lowest. So 5 is the highest one, and 1 is the lowest one. So we will swap them if the rating is same. Let's take another example. So we have over here these restaurants, which is I think 5, and they are saying that it is vegan friendly is 0. So we'll remove those which are saying they are vegan friendly. So for example, we need to remove this.
No, it says that we if vegan friendly is
Yeah,
0,
sorry. We should
we
take.
can include both.
Yeah, sorry. We can include that vegan friendly. Sorry. Yeah.
Cause if it is like vegan only, then we need to pick like those. If it is
Yeah. Correct.
non-vegan, then like a non-vegan guy can
Mm-hmm.
maybe use the vegan option and the non-vegan option too.
Yes. So max price includes all these because it's 50, so it covers all these. And max distance is 10, which is also included in that. So now we need to sort the whole array on the basis of rating and on the basis of ID. So first of all, now if we can see, we have two, these two. Sorry, first of all, we need, this is the highest one because it costs 10 rating. The first one is this, ID is 4. Then on the basis of this, these two, we need to sort it on the basis of ID. So now 3 is more than 2. So
that's like a second step after this. So first, like maybe you can just pick in the same order.
okay. So let's take on the same thing. And then these also, so let's take this first. Yeah, so this is the highest one, and then this is the, so now these two have the same ratings, but we need to sort it on the basis of ID. So now we'll swap these. We'll swap this. I'll just write it down over here. And after this, we'll just need to swap this. So instead of these, now we have this result.
I'm not sure like why this problem is a hard problem, because it's
It's a medium.
plain filtering and sorting.
Yeah, actually, it's in Python, I would say it would be 2-line thing. You just need to sort on the basis of
First filter and then sort. So what should be the
Or like just take a product which you just put all the things which are filtered and then keep removing like a match case and like a custom comparator. If the rating is same, then look for the IP.
so what's the time complexity of this problem?
So first order of n for looking for items. which
Order of
needs
n
to
for
be
filtering.
For filtering, and then let's say there's k items left. Then put all of them in that heap. It should be like k log k, and
But-
then keep on removing.
What's the worst case?
Worst case would be n log n. That could be even if you sort till it is n log n.
Yep. So let's say like if for anyway, like for filtering, we have to go through the entire array. So it should be order of n. And let's say after filtering, we again got the entire array. Okay, we are not like eliminating any element. And then let's say all the ratings are different, then we have to like sort them by rating. Okay, so it will be n log n.
Mm-hmm.
So anyhow, if you do sorting also or do a priority queue also, so both have the same complexity.
Yeah, we can use priority queue. We can use the in-place sorting, merge sort, or like quick sort. Okay,
Yes.
it should not matter, but in the worst case, the complexity is going to be n log n.
Mm-hmm.
Well, it's like a plain sorting question, like after filtering, sorting, like use any kind of sort.
Mm-hmm. Yeah.
Yes, I agree with that fact. Yeah.
Anybody haven't understand this question or want to have some other approach? Have some another approach? Seems like nobody has problem in this particular question. Okay, so this is one of the approach which we discussed, like either take a priority queue and then sort take a and then filter it out, or make us do a sorting, whatever sorting technique you want to apply, and then another, and then take a filter it out, or you can filter it out before and then do a sorting. Either of it you can do. I think this would be an easy question, I would say, then not so medium. Okay, so can we move for the last question? Okay,
Yes,
so
okay.
okay, so okay, so for this particular, this is from Hard Bucket, and here what we have to do, it's a two-dimensional grid which there are 4 types of squares. So one representing the starting. So let's take an example of this. So which here it is saying 1 is the starting point, 2 is the ending point, and 0 represents the empty squares, and -1 represents the obstacle that we cannot walk over here. So what we need to do, we need to give them and the one thing is, actually we need to return the number of 4 directional walks from starting square to the ending square. So we need to return the answer of how we are approaching. We need to reach 2, and how we need to reach 2, we need to reach by 4 directional walks. Like from here we can go right, down, and if we are here also, if this is our cell, then here we can move up, left, right, down. So we need to give the answer of how we are reaching to that particular destination, which is 2. And one thing more, I think we need to traverse all the zeros over here. So it's saying return the number of 4 directional walks from the starting square to the ending square that walk over every non-obstacle square exactly once. So if we are traversing by one path, then we cannot traverse that particular cell again to reach to the destination.
And I believe, like, help me understand if I'm getting this correctly. The problem statement is saying that we have to cover all the zeros.
Yes.
We cannot like leave any zero.
Yeah, we should. That's one of the point. Otherwise we would reach, like, from here, starting from 1, going down, we'll be reaching directly, and then going right, we'll be reaching directly to 2. But that's they are saying we need to cover all the zeros over here. So that's one trick. Whenever you are taking a path, you need to check. You should travel all the zeros, and you should not repeat the 0 while you are traversing that particular path. So for example, over here, they are saying they are going to 0, 0. I think I put like this. They are saying they are 0, 0, 0, 1. I think they are going like this. Then I think
I believe it's the first row, starting from 1, traverse all, and then down,
then down, then
left, and then down, and then the
right.
2. And then the other thing is
down,
up, right, up,
then up,
then right, then
right,
all the way to the end.
Yes, all the way to the end, and then
down,
going down, and then coming back, and then reaching to. Yeah. So these are the 2 approaches, paths which they are saying. And this one, okay, this is another. So
let's talk about the first problem only. like the
Okay.
first example, and then we can go to the second.
Yeah. So
What
any
kind of
approach-
logic we can apply here?
yeah. Seems like we are going the depth of all the paths. I think depth for search would works best over here.
So there are two options, okay, BFS and DFS.
Mm-hmm.
Will BFS work?
EFS might not work because we'll visit all neighboring cells and then go ahead. And then we can step, if we want to step over it for the one path, it will say it is already visited.
That's what I'm thinking, but if anyone has any because BFS is like not a solution here. I'm not sure like BFS will work or not.
But yeah, even I want to see like if BFS can work.
Yeah, even for DFS, like when we are doing the DFS, we have to make sure that all the zeros are covered before we reach 2. Okay,
Yes.
so for this problem statement, 1 can be anywhere. Okay, and 2
Yeah,
can be anywhere.
yes. 1 can be anywhere and 2 also can be anywhere.
So like, do we need to do the first pass to figure out where the 1 is?
The one. Yeah, where is the 1 or where is the 2, or just need to check where is the 1.
I don't think
Yeah,
like, we have to like figure out that 2. Okay, but do we need to count like how many zeros are there? Like, is that a requirement?
Yeah, we need to find out where if all the zeros are covered. So
Yeah, that's
it
not
should
a
be
that's
either
not the
count.
requirement, but it will help to actually make sure that we covered all the zeros.
Right. So I think like maybe we have to do a scan first of this grid.
All the zeros. Like walk over every non-obstacle sphere exactly once. So that's one of the requirement there.
Yeah. So we have to do like one pass of the whole grid and then figure out how many zeros are there and what's the starting point of the 1. Okay. And then from that 1, we have to do the DFS to figure out how many ways like maybe we can reach 2, making sure the length of the path by which we can reach 2 from 1 should include all the zeros. So yeah.
So we need to take one visited also, like to make that we should not traverse that particular cell again.
Yes.
And we might need also something of backtracking to say, okay, if I have
yeah, that where I
Like
was
cell.
watching that. Yeah, so we need to make them again as it is also, because we need to traverse them again if we have another path. So we need to do a backtracking.
True. Yep.
Okay. So
And
is this one approach? So
I think so.
So-
Is there a possibility that like we can traverse the same path again? So let's say like we are like in this example we are starting with 1, okay, and when while we are doing the DFS we go all the way to the right, down, then all the way to the left, down, and then reach 2, okay, and then so this is like where we started, like the 0 on the right of the 1, okay, so
Yeah.
so it will give us like one path. Now while backtracking we have to again mark all the we have to reset it, like we have to again mark, okay, like we haven't gone through those because we have to like redo the visited matrix, and then maybe we start with the again second neighbor, which is 0 at the bottom, like at the bottom of like just below the 1, okay. Yep, yeah, I guess like that should work.
And then the other 0 could be used again.
over here, so this is the same question. I think the only difference is, example, this only difference is over here. So my question is, how it is more than two paths? Because
can-
over here, they are going to this direction and down.
so in this case, like you can go all the way to the right, then one down, all the way to the left,
And then,
like
same.
make a
Yeah.
Z, make a Z, and then the other one that you're telling, like, go all the way to the down, then
Yeah,
right all the way up, and
yeah.
then
And
right.
extreme right, then going down, then coming back, then going down, and then reaching over here.
And
One
then
is one is zigzag like this, I suppose. No, this. So, okay, so I got it. Like for each particular cell, they are going traversing all the four directions and checking if it is not traversed, then we will be traversing that path.
Hmm. And if the cell is already in one path, we don't want to visit it again. But if it is coming in any other path, then yes.
Sorry, and
So if it's like when you are, it's something like a concept of visiting and visited. So if something you are visiting, you don't want to visit it again because it is already in your path. You don't want to step over. But if you are taking another path, then you want that cell to be used. Like you are going forward direction.
Mhm.
So if you use right 0, then like the 0 should not be used in the same path again. Like if you start from top and then your right 0 is coming back again, then it should be used.
Hmm. Okay.
So what's the question, like, Sonia, you are asking?
So I'm saying that, sorry, no, go ahead.
Go ahead.
Actually, I was
Sorry.
saying, so if it is over here, so it should, for example, my point is right now over here, and it is going to all the four directions to check like where the path I should follow. If it is covered by this path, then we'll not be traversing that particular cell because it is already traversed. So we'll be traversing another. So one of the question is, okay, so we are already making them a unmarking it by doing a backtracking. So okay, I was thinking like how if we are already traversed one path, then how if another cell is here, how it would be taking that another path because it's already traversed.
Yeah, so we go down the tree, like let's say from level 1 to level 2 to level 3 to level 4. Okay, we mark them. Then we again come back to the level 3. Okay,
That's the point.
and then level 2, and then unmark level 3 as like not done, and then go to the other path.
Okay, so at the level 2, we unmarked all the level 3 ones, and then at level 2, if we check there is another path which that can follow, it will go to the again follow that path and will go to the level 3.
Yeah.
And
Because
then
at any level deep, like when we are in the recursion, this DFS
Mhm.
recursion,
Yeah.
at any level deep, like let's say you start from first to level 4,
Mhm.
at any place in the recursion, we have to explore all the 4 options. Okay, like
Yes.
all the 4 neighbors.
Mhm.
Okay, so we choose like maybe left neighbor, try to see if that leads us to the answer. Okay, if not, like we will backtrack to that point. Okay, take this case like which you have highlighted. Let's say like you start with 1, go one right, and then 1 down. So the one which is highlighted in this example.
Yeah.
Okay, and then from this 0, we will start going to the left. Okay, and go all the way down, then right, and then up. Okay,
Yeah.
and then right, and then 2.
down.
So we found one answer. Okay,
Yes.
now we will backtrack, and while we are backtracking, we will mark all of these zeros as unlisted again. Okay,
Yeah, till
and
over
then
here.
and then we are done with this path.
Yeah.
And then we will choose the, let's say, bottom one.
Okay.
Okay, bottom one, and then we will again do the DFS. So, but we will not find an answer because we will not cover all the zeros. Okay.
Yeah, will not be covered.
Then we will again backtrack and then go to the right. Okay.
Yeah, over here.
And then again explore. So that's how like backtracking will work. While we are again coming back, we will unmark all those.
Yeah, got it. Thank you. Yeah, so anyone has any problem on this approach and has any problem of understanding this question? And anyone wants to discuss any other approach?
So BFS could not work here, right?
Yes, it's like BFS,
yeah.
I don't think like it will work because BFS explore all the children. BFS is well suited for if we have to find the shortest path. But in this case, I don't think like BFS will work.
Or what if it is told like we have to not visit all the zeros? Like I'm just thinking about now variations.
Like visit all the zeros. What's your question?
Like we don't have to visit all the
zeros.
cells, like all this. Then still it would be same.
I think then also normal DFS would work. We don't require doing the backtracking at that point.
No, we still might have to do backtracking.
Yeah.
We don't want to revisit the same cell. Or might be we want to visit it.
Yeah, I believe like in that case we can follow like a different approach, and I'm not sure like need to try it out. So let's say like we start with first one. Okay, and then like for each cell we will see how many ways like we can reach that cell.
Yes.
Okay. So in case of the cell 0, which is on the right of 1, there is only like one way we can reach there. Okay, the 0 which is at the bottom of 1, there is only one way we can reach there. Okay, now the 0 which is to the diagonal of 1. Okay, we can reach it by sum of number of ways we can reach to the left or reach to the top. Okay.
Agree. But it has to go 4 directions.
Yeah, but here there are 4 directions. Yeah, so it may mess the things up.
Yeah, then I think this is as good as like a unique paths 1 and 2 problem. But here I have to go 4 directions. Then can I still directly use DFS and get the answer?
So how about if we are moving like for that particular path, we are moving over here and then we are moving down, then going again this right and then going then directly to like this particular 1 down 0, then extreme right, then down 2. That's one path to reach 2. Then this right, then down, and then over here down and then right. So there can be multiple ways because it is not required to cover all the zeros. Then there are multiple ways we can reach.
Maybe like one of the way is just at every instance do the DFS, the exactly same solution that we discussed before.
Yeah.
We have to add an additional constraint that we have covered all the zeros. Okay, but in this case, like we will remove that constraint.
Mm-hmm.
Okay, but backtracking still we have to do.
Yeah, it's still backtracking and then like explore in how many ways, like maybe we can go there.
Let's
Not
see.
taking a backtracking, we can take an external array and store how many paths we like the normal uh, uh, DP or something, dynamic programming question, like how many paths we can reach that particular destination.
No,
That
but here there are 4 directions. I don't know how we'll put that in DP.
Because if there are only 2 directions, that's a right and down, then you are guaranteed, like if you reach the diagonal 0, which is diagonal of 1, okay, you have already covered the one at the top right of 1 and one at the like bottom of 1. You have already covered those. So you are like sweeping that whole array horizontally and then vertically. First row, second row, third row. Okay. So by the time like you are at any index, you are guaranteed that you have covered the index which are on the top and all the elements which are on the left. Okay. So you are building on the previous answer. But here, as Asim is saying, you can also, you may also want to include the answer which is at below you. Okay. So I'm not sure like if that approach will work here.
No, but let's say so in the same scenario, if I use BFS now, I go 4 directions, make them like that is one path. They explore their children. They explore their children. Don't know if that will work or not.
We can give it a try, and like I need to like leave for the office, so I'm like dropping right
Okay.
now. But
Sure.
keep discussing and like maybe post it on the Slack too, so maybe we can continue the discussion.
Sure.
Thank you, Sonia.
Okay, thank you so much, Gaurav. Seems like no one else has a problem, so let's stop sharing. So anyone wants to discuss anything else? Okay.
You can
Anyhow,
stop recording.
sorry?
You can stop the recording.
Oh yeah, I'll stop the record.